quick show of hands, who here thinks like writing meaningful, good tests is like really hard? Yeah, at least some people do. Who here really enjoys writing tests? Some. It's interesting, how we think of ourselves as people who like a challenge and like to work on interesting problems, but still maybe tests are not as popular. Cool. When writing tests for your Android apps, it's really easy to end up with brittle tests that make changing your app harder and are quite hard and expensive to maintain. Hi, I'm Florian, and after a decade in social and mobile gaming and a stint in helping people turning off and on their lights with their phone, I'm now working at an accounting software company named Xero. And today I want to take you on a little journey about how at Xero we failed to write good tests for Android apps. And then I'm going to tell you a little bit more about how we learn from these mistakes and how we're applying some very simple architectural principles to write subcutaneous tests and fast-running UI tests. But first, I would like to give you a definition of what good tests actually are. And I hope this will enable you to reflect on your own testing practices and maybe make one or two changes or keep everything like it is. Cool. But what are good tests, right? Who better to ask than this person? No, that's not me. It's someone. This is actually Ken Beck. And Ken Beck brought us the JUnit testing framework and also the very influential book, of course, Test-Driven Development by Example. And a while ago, he posted a blog post on Medium with the title Programmer Test Principles. So here's what he has to say. He says our tests should minimize us waiting. So that literally means if the test runs for a second, that's really good, right? We can run the tests really often. If they run for 10 seconds, that's probably still all right. But if they take 1 minute to run, maybe we go to the coffee machine and get a coffee instead and return after 30 minutes. So they should run reliably. We all know those tests, right, that randomly fail and that they take a lot of our time. We say probably we should at this point just delete the test and find a different implementation that we can test better. They should predict deployability. So now this is a bit interesting, right? Like, of course, for us, deployability just means we can build our app and then we can deploy it into the baseline, everything's good, right? So like, I would frame this a little bit different, and I would actually say it means that our app actually fulfills the requirements and does what we want it to do. And then those tests should respond to behavioral changes. So whenever we change our implementation and the implementation does something different, our tests should start breaking, right? Because now the tests should test a different behavior. But they should not respond to structure changes. So whenever we restructure our code, preferably our test shouldn't be prone to start fail. They should be very cheap to write, right? None of us is paid to write tests explicitly, at least I suspect. We're meant to solve our customers' problems. And they should be cheap to read, right? Like code tests get to write a lot more than they are written. And lastly, they should be cheap to change because our code is inevitably going to change, and so now we need to adapt our test. Cool. So before we jump into our mistakes, I want to give you a little bit of a context, right? So as I said, Xero makes a cloud accounting software for small businesses. Our Android app is in development since 2013, so keep that in mind. At the moment, we have 15 developers in 3 pods across 2 countries, and we're hiring iOS developers as well, and all kinds of other developers. We have like booths out there if someone is interested. And as developers, we are responsible for quality, right? We don't have a QA that is responsible for testing and like pushing everything back to us that is not cool. We have to be responsible for that. We have some help identifying what the problems might be and what we should be testing for, but like we are responsible for testing. And above all else, business rules matter to us. That might be completely different for your app, but for us, we can get away with an animation not working. But like if the text calculation is incorrect, we probably halt the rollout and like do a hot fix immediately. Okay. So let's talk a little bit about what we did in the past, right? Everyone knows that the testing pyramid, or as I call it, the inverse ice cream cone of testing. But everyone knows this, but like I guess every single one of you would have a different definition of what the testing pyramid actually means. So in these slides, it's solely my interpretation. So you have unit tests, and those unit tests test your units without the dependencies, and we have integration tests that like combine all the different units and parts of the system and test them in combination. And often in Android apps, we have like a few UI tests that instrument the system using the UI and test that one, right? And so let's look a little bit more in depth what that meant. So for us, because we had a layout architecture, our unit corresponded to the implementation of a layout. So we ended up having tests like an invoice repository test. We had like an invoice presenter test because we had a model view presenter pattern. But what about the dependencies, right? How can we test without dependencies? Dependencies because we're dependent on them. So usually what people do is they replace the dependencies with test doubles, and that might be fakes or stubs. Or in this case, or in our case, we used mocks, right? And mocks, they're getting under my skin, but not in a good way. And I'm going to tell you a little bit why that is, right? So mocks seem really useful in the beginning, right? You potentially just have like one function call, a factory method that creates your mock, and then you have your dependency fulfilled. Great, right? Only that now they work great when you do a function call, but you don't expect a result, or you're not reading value from them, because all the values and responses are by default null, right? So they don't enforce any meaningful values. So to give you an idea of why that is really bad, our app is pretty old, right? So we used to write all of our code in Java, right? And Java is very slack with its null values, but now we've started converting all of our code into Kotlin. And of course, we try to avoid optionals as much as possible, because often we were pretty sure that our business code always relied or provided the value, right? But now, simply by changing the language, hundreds of tests broke, right? Because suddenly they were getting null, and they didn't like those nulls. And that makes you think, right? What did we test in the first place, right? Because like if those values are somehow relevant to our business logic, we have never tested them before, because we should have just failed in the first place, right? And so they're also very ignorant to changes. So if you're refactoring your code and your model or your dependency gets a new property, again, the default is null, nothing breaks. We have no notification apart from probably our breaking test. So essentially, we end up with dependencies that have a completely undefined behavior. And that makes it very hard to reason about those tests. Are we, as I said, are we testing the correct thing? So that also means they're probably responding to structural changes. And they can be quite unpredictable. And then, like, if suddenly, like, one little enforcing of the non-null value breaks 50 tests, that can also be very expensive to change. So let's talk about integration tests for a moment. So because the integration tests don't, like, they have real dependencies, they don't suffer from the same problem as much, which is great. But they might hit our backend, right? We're integrating also the systems that are not in our control. So now we're depending on a different system. That also comes with its own problem. Like, I have seen these tests fail because, like, the staging system is down. And because you still don't want to include the UI into your integration tests, right? As I mentioned before, we were using a model view presenter pattern. And what that led to was that we had, like, problems at, like, the very UI edge because we still had to mock it. And so now our presenter was calling into a view and then relying on the view calling back into the presenter. And then that would trigger something new. And, like, I'm not saying you need to end up with situations like this if you're using the MVP pattern, but, like, we definitely did. And now we're, like, in even deeper problems because, like, now for this mock, we not only need to mock the values, but we also need to mock the behavior, and we need to capture some callbacks and then execute them in the right order. And of course, that means that we suffer from this bidirectional data flow when we're mocked, and that makes it again expensive to change, right? Because, like, now we have, like, mutually bound to the timing of interactions of the part of our systems. And we are relying on external systems to test against, right? Which might add again some unreliability and unpredictability. So what about UI tests? I guess those are the favorites of everyone, right? They can be really slow. And I think what that usually means is that we're testing the full stack top to bottom, which just makes it slow. But it also has some other problems, right? It's really hard to set up your tests so that you can test permutations, because if you need to log into your app as someone, right, and that account has a specific role, maybe you want to test with all the other roles as well. Like, and it gets really hard because you need a lot of, like, either you need a lot of different accounts, or even better, you need a backend system that kind of provides some kind of repeatability. So whenever you start running your tests, you're resetting to, like, back to a normal stack. And I have a funny story for you why our UI tests were slow, or, like, even slower than they needed to be. So as I said, I'm working on accounting software. So, like, one of the features is to create invoices in our app. And so we had a test that created an invoice in our app, saved it, and then went back to a list of all invoices, and then scrolled in that list to find out whether the invoice has actually saved, right? And that sounds fine. Only now imagine this test running again and again and again and again and again over years against the same account, right? Because we didn't have that backend system, because someone needs to write that for you and maintain that for you. So we were relying on, like, a live account. And when I looked at it, that test actually by itself ran for 5 minutes because it was scrolling. Like, after 5 minutes, it was like, ah, yes, the invoice I just saved is in this list. So maybe not the smartest move. So, as I said, they're, like, pretty slow. They can be really unreliable, right? Like, you probably all know one Android developer is saying to the next, oh, you should have turned off the animations on this test device because otherwise the UI tests don't work properly. Or, have you tested it against API 21? No, you need at least API 22 for this test to run reliably. They're I find very tedious to write, and they can be quite hard to change, and because your UI usually changes. The tooling is pretty, yeah. I don't know why we can't programmatically turn off the animations, for example, or I don't know if anyone ever dared to try to use the Espresso test recorder. I think even as someone who could tolerate like a 5-minute scrolling test, the Espresso test recorder is beyond me. So they definitely maximize our programmer waiting, and they can be expensive to write and expensive to change. That's just that. So let's look at a little of conclusion. So one of our problems definitely was mocking, right? And the solution might be to mock as little as possible. So mocking is usually fine if you just mock one layer. But as soon as you start returning other mocks that return other mocks from your mocks, and you're having a tree of mocks, that's probably not the right thing to do. Then the bidirectional data flow, it makes it really hard to have a system that is not depending on time, the control flow that's really weird. So maybe we can use a unidirectional flow using viewmodels or something else as unidirectional flow. And so the tests rely on integrated setups, right? As I said, we have different roles, we have different permissions, we want to permutate all of this and test all of that. So maybe we can invest into infrastructure, the test setup easy and parameterizable. So, and the UI tests have a broad scope, and they are really slow. Let's talk about the solution later. So let's go back to the drawing board, right? If all of this is so horrible, right? Maybe we shouldn't be testing. But as I said, to us, business logic is really important, so we probably do want to test. And so two things happened. The first thing was that we got together this group of 15 Android developers, and we talked about how do we want our app to look in 2 years' time, right? How should the architecture look? And so we came up with a few building blocks, and we said, we want to be stateless as possible, we want immutable data, and we're going to use Android architecture components and drive our UI just from the state of the view model. But we didn't have any idea on how we could actually test that, right? And we didn't want to make the same mistakes again. And someone mentioned the idea of subcutaneous testing. And if you are anything like me, at that point you're like, subcutaneous testing? I had certainly never heard of it. And turns out it's not a new idea. In fact, it can be traced back to a blog post by someone called Genome from 2010. So it's newish, but already 9 years old. And here's what he has to say. Subcutaneous tests are important because we want to be able to test business logic with the entirety of the system in play, with the exception of external connection points such as the user interface and the external services. Right? That sounds very useful because we are interested in that business logic. While the unit test focuses on small-scale design, a subcutaneous test does not address design, but instead tests basic inputs and outputs of the system as a whole. Right? Let's unpack this for a second. So we're excluding external connection points, so that literally just means we don't include any UI in our tests, and we don't include our backend systems in that test. Instead, we test basic inputs and outputs of those external connection points, right? So, okay. A user interaction is an input into our tests. The view model state is the output of our test, and we can verify that like after an interaction, the state is correct and has produced the right output. The calls of an API of our system is an output similar to the view model state, because now we can verify that a specific API call has been made and parameters. And the responses of an API is an input into our system, so we can use it to do these permutations of data by injecting different things from the API. So let's look at this, how this looks architecturally, right? So we have the UI on top, and like for us now, we have a view model, and the view model talks to the interactor and talks to the repository, and that might either get the data from the database or from the API. But like we don't test the API, right? What we actually do is like in our testing setup, we spin up a little web server, and that web server we can use to inject testing data to requests that are made to that particular web server that is also running as part of the tests. And then we can also use it to verify the output, which are called into the API. On the other end, we basically can verify the output of the view model. We can assert on the state of the view model, and we can interact with the view model the same way the UI would. And what happens other than that is completely irrelevant, right? Like the only two boundaries we actually care for is the interface of the view model and the API. Let me quickly show you how this looks in tests for us, right? So as I said, we made like a few investments into our testing strategy. So basically what this does is take the JUnit test rule, which are super useful because you can spin up something at the beginning of your test and tear it down at the end. And basically our application gets spun up using a data graph. So the only thing that this really does is like spin up a specific data graph that is as closely as possible, as close as possible to the real data graph, right? There are some things that we can't spin up, like, for example, shared preferences or remote configs. So what we do instead is that we enable them to be provided by different means. But we do spin up like an in-memory database, for example. And then we configure our system to be logged in. And so what this does, it actually sets up a networking response for a specific URL. And that gives back a specific response. Now you see how I said we use sensible defaults, right? So basically this org response has probably like 40 properties. Like we could specify each and every one of them, but like we usually don't, like if we don't need a specific value to be set. But like this allows us to set permissions or the name in this case very easily if we override the default parameter. So, and then let's look at the test case, right? So this bootstraps the view model, right, with a specific configuration. In this case, we're bootstrapping something that edits line items in an invoice. And we configure this with like a single line item. But like just by spinning up, like we implicitly make the call to actually load the org, and the sky is really the limit here. We could also fill caches in our database or like make 20 networking requests just like it, because that's what the view model depends on. And then we set up another networking response because like now what we're going to test is whenever the user types a different description, we want our backend to be able to categorize that to like a specific account. So in this case, we say we don't get any suggestion back. And so now we do the same thing at the UI. We just type the word Frankfurter in the description field because we're running a hot dog business. And So now we can do the assertion here, right? We assert that the suggested account ID in our line item is still null, and we verify that the request that we expected actually has triggered, and that the parameters that we expected to be passed have been passed. Cool. So let's verify that against our definition of good tests, right? So we're testing the whole business logic, which means we can predict our business logic and we respond to behavior changes, but we don't respond to structural changes because we literally know nothing about the structure. We don't care about the implementation details. If we do, we can still write a unit test for those little implementation details, right? But we don't have to. I'm not saying we shouldn't either. So we invest into some reusable infrastructure as code, which means we can do refactorings on this. If our network response has like a new parameter, like this is all done in code, not in configuration. And so that makes them quite cheap to write, to read, and to change, we find. And we exclude the API and the UI, which minimizes waiting and run reliably. There's like this little asterisk, which is just because, as I said, we're running an in-memory database, and we're using roboelectrics for that. So the first test is really slow. The first test takes about 10 seconds to bootstrap roboelectrics, and then we run the other 3,000 tests in a minute and a half. So testing the skin, right? I promised you I'd talk about fast running UI tests, and I have a little bit of a surprise for you, because maybe that will be a bit of an anticlimax. Because it turns out we can use the exact same principles that we had already, right? Because our UI is completely driven by the state of the view model, right? Now, if we input state into our UI, we can verify that the UI draws correctly. And whenever we interact with the UI, we can verify that they trigger the correct interactions on the view model. We don't actually need to test all of this in combination. To give you like a little bit of a better idea of how that looks and why I call this fast running, right? So these little test cases that you see, like each and every one of them takes about like a second. And the only thing that they do is like this, like type something into a specific field and then check that the changes have been set into the view model. Or they test that a specific property of the view model actually draws the corresponding part of the UI correctly. We don't actually test those things in combination, right? Like we don't test our business logic at this point because we already tested those in our subcutaneous tests. So how does it look in code? So we do the same thing. We have a test rule that bootstraps an activity, and before each test case we set up a robot. The robots are not really necessary, but what they help us with is they make our tests functions reusable, but like also they make sure that the test code runs on the right thread, because we need to sometimes run things on the application under test and sometimes on the testing application, because that's how Espresso works. So this is like a very simple test case, right? So we bootstrap the activity and then we say, we want to verify that a specific text field displays the correct string. So we actually use the robot to set that into the state, and then we assert using the robot that actually that field matches the correct text. And that's it. That's like our 1 second test code for that particular field. Right? Similar, if we want to interact with like a specific activity. So in this case, we're pulling to refresh. So we pull to refresh on the UI, and then we verify that the refresh has been called on the view model. So I just extracted these from the robot, so you can see those are just really Espresso code, and like in this case, the view model is a mock because we don't really need to do anything deep there. So, as you can see, this need to be a bit quick, but so this basically satisfies all of our requirements with a lot of asterisks, right? So those tests are, of course, still slower than unit tests, right? Maybe Project Nitrogen will help with that in the future. They run a lot more reliably. Then the reliability is not perfect because we're still using Espresso and like Android devices. They somehow predict deployability, but like we don't actually test the interaction between different activities. So that might be still something we decide to do in a different way later. They respond to behavior changes because the API surface of the viewmodel changes. They not respond to structure changes because they don't know anything about the structure. And they're relatively cheap to read and cheap to change. And we found the first one is a bit more involved to set up. So, but then afterwards they're also cheap to write. So in summary, we set up a definition of what good tests actually are. And then we looked at our traditional approach of how we fail to write good tests or like how we fail to satisfy our definition. And then we explored a different approach using subcutaneous testing and applying the same principles to UI testing. And I hope this enables you to reflect on your own principles, right? I'm not saying this is how you should test. You need to find out how to test your applications properly. But maybe this provides useful for you. Thank you.